Right, the second example I'm going to do today is about how to turn recurring decimals into fractions. Now, I'm just going to remind you a little bit. If I just had 0.2 repeating, all you do is put it over 9. If I had 0.6 repeating, all I do is put it over 9. This one can be simplified. So simplify if you can, 0.1 repeating, 1 over 9, etc., etc. This is a little bit trickier because not all of the numbers are reoccurring. If this was 0.15 and both of them were recurring, then I could put it over 99, and then I could obviously simplify that as well because they're both divisible by 3. But they're not both recurring, so I need to use some algebra to do that. I don't know if you remember this method, but I'm going to go through it. So I'm going to call this number x because I can. I just need to represent it somehow. Then what I'm going to do is I'm going to multiply it by whatever I need to get rid of the non-recurring decimal. There is only one number that's not recurring, so I'm just going to multiply both sides by 10. So now, see how I only have one number recurring? So that makes my life a little bit easier. So these two are equivalent equations. Then what I'm going to do is subtract my recurring number because frankly that's a bit annoying and I don't want that. So what I'm going to do is this minus my original number. So I'm going to do that. I'm going to do 1.55555 minus 0.1555555, right? So what I'm going to do is, I mean, you can write this out if you want. You can actually do it as a subtraction. So if you did like 1.5555 minus 0.15555, see how all of these are just cancelling out. It doesn't matter how many I've got. 5 minus 1 is 4. 1 minus 0 is still 1. Okay, so you should end up with 1.4. This, however, if I took away this from this side, I also have to take it away from this side. And I said these two things are equivalent at the start, right? So if I subtract the original number from this side, I'm also subtracting the original number from this side. So I've got 9x. Now what I'm going to do is get x by itself. So I'm going to bring the 9 across as a division. Now you cannot leave it like this because we cannot have decimals in a fraction. So I'm going to multiply by 10 to get rid of it. But that means I need to do that. So if I can't simplify, I'm done, but this can be simplified. So I'm just going to halve both of them. So I get 7 over 45 equals x. Now I know I can't do anything more because 7 is a prime number, so obviously this is unable to be simplified further. If you can't remember this method, feel free to let me know and we can go through some more examples, or you could watch this again. But basically you make whatever your recurring number is, that's x. Then you multiply it by whatever you need to get, so if there were 2 non-recurring decimals, I'd be multiplying by 100. 3 non-recurring decimals multiply by 1,000, and so on and so on. And then this becomes the equivalent of that. Then you subtract the original thing from both sides. Then you're left with something equals 9x or 99x, whatever it was that you had to multiply by. Divide, get rid of your decimals, and simplify if possible. Some people have trouble with this, and that's okay. It is a bit complex. Please let me know if you'd like some more help.